Hello, this training video will have a focus on mold design as if the user is new to Cimatrone. I'd like to start out by going over some of these icons. You may not have the same icons here that I do. I have mold design, electrodes, a couple of die wizards, and then the parting setup wizard. So you may not have the same icons if you don't have the same thing turned on in the licenses. It's not a big deal. Over here we have new. This is for creating a new document. You could create a new part file, a new assembly file, a new NC document, or a new drawing. Again, if you're missing icons here, it could be what's enabled in the license. The next one we have is open. This Cimatrone browser is much like the Windows browser with a couple of key differences. First of all, by default, this filter up here is only looking for Cimatrone files. So if I had a step file or an IGES file or a CATIA file in here, you're not going to see it. If you switch this over to all types, you might see it, but you're still not going to be able to open it. Here's a step file, and we don't open step files. You have to convert them first. Also, while we're here, I'll point out, let me open up a different folder. In the Cimatrone browser, you will see little plus signs next to some files. This plus sign means that underneath this assembly file, I have part files and sub-assemblies. And you wouldn't see that in the Windows Explorer. Also, in the Cimatrone browser, if I right-click on an assembly file, I can choose Dependent Copy, and that would allow me to paste it into a different folder and bring all of the connected documents with it. So it's a quick and easy way to move around an entire mold design that you wouldn't have that option in Windows Explorer. Okay, so next we have export and import, and this is precisely how we convert files from STEP or IGES or some other format. So let's go ahead and choose import, and I need to get into the right folder. Here's the step file that we're going to work with. I hit the optional expand button to look at the options, and I'm just going to go through a few of them. On the general tab, you've got filters, so you can include or exclude certain geometries from coming in during the translation. Next, you've got some other parameters like fix entities. This one will automatically try to correct problems that the ACES kernel doesn't like. The simplify faces and edges sometimes is required, but that can also be done inside of a document. Basically what that would do, if you had what ought to be a cylinder face isn't being recognized as a cylinder, there's no center point to it, that type of thing, this would fix that problem. But again, it can be done inside the document, so it's not required that you do it here. It's just an option. Next, we have the file units. If this is set to file units, that means that however the file was written out, it's going to come in. So if you want to be 100% sure that it's an inch file, you need to click on inches. The geometric tolerance we don't normally change, but what you should know is that if I switch this from step to parasolid, this geometric tolerance is tighter. It's down to 0.001. This is always a metric value regardless of the units here. And so the parasolid default tolerance is 0.001 millimeters, and the default tolerance for step is 0.01. And I have seen examples where tightening this up a little bit was better, and I probably would just try like 0.005 millimeters if I wanted to see a different result. Next we have create assembly, and this could probably be better worded as maintain assembly. So if the step file was written out as an assembly file and this box is checked, it's going to maintain that assembly. If it wasn't written out as an assembly file, this button will not magically create one. However, this one does kind of magically create one. It can take multiple bodies and push them out to their own part files and magically create an assembly from a system that didn't support assemblies like Visi. And the last option here is object to set, and this would take multiple bodies and push them each to their own level. Normally this one is on by default. It's a good option because if it was written out as an assembly, probably it should be read in as an assembly, and if it's not an assembly, it's not going to magically force one. So this is the right default option to have. Okay, here's the result of the step translation, and we're going to pretend that we're both seeing this part for the first time and we want to get a little bit familiar with it. Probably the first thing that I would do is I would go into the measuring tool, and up here along the top you've got measure distance, measure angle, measure curvature, or data. If I set this to data, and I'm careful to see that the object filter is pressed in, I'm picking this as a body. This is taking kind of a long time, which may lead me to another little tip that we'll go through. Okay, so what this is giving me right now is a bounding box. You can see that we've got the X, Y, and Z length, 6 by 1.5 by 4. So that gives us a feel for the size of the part. If I know the density of the material, I can plug that in here and find out the weight. If I know the injection pressure, I can find out the clamping force. So this is just a quick way to help get familiar with the part. As I said, that took kind of a long time for that interrogation process. So one of the tools that we have that I try not to use, I try not to overuse, is check and fix entities. Um, Normally I don't do this in every job, although it used to be kind of a suggested practice. Now I only use it when I suspect there might be a problem. And I'm going to choose all entities and then hit this first one as just check, and we'll see if it found any problems that the ACES kernel doesn't like. And again, I wouldn't do this in every job, although some people might. I would only do it if I saw things were taking longer than expected, or solid operations weren't happening as I thought they should. What I mean by that is failures of solid operations. Okay, so it has a problem here. We've got one small face, one invalid body, and 325 invalid faces. We'll go ahead and remove the small face. We don't have any heavy faces, and we'll try to split the unsmooth faces and do an automatic fix. Actually, while this is working, I just noticed that fix invalid entities is checked and you cannot uncheck it. So that's going to happen regardless of our options. We don't really have any unsmooth faces, so that split unsmooth faces is going to be irrelevant because there aren't any. We are going to delete one small face, and again, we don't have any heavy faces, so let's see what happens. Okay, so I still have a problem. I got one invalid body and 325 invalid entities. Let's see if we unstitch and restitch will fix the problem. This is actually pretty uncommon too. Like I said, I don't normally use this check and fix entities, but I could tell it was taking a long time when it was interrogating the solid body, so I immediately suspected something was wrong. If this doesn't fix the problem, we may try translating it differently.